Today we'll be working on Lesson 312, Complex Numbers. But before we start on the practice sheet, let's review what is a complex number. A complex number is made up of two parts. A real part and an imaginary part. A real part is usually all the numbers that you've been working on, like a natural number, for example, 2, or an integer like -3, or it could be a rational number like the fraction 1/3 or the fraction half, or it could be an irrational number like the square root of 3 or the square root of 2. Imaginary number is something new, for example like 2i, 1i, -i, 3i. So where does the I come from? For the longest time in history of math, every time you come across a number like this, square root of -4, you would say that this is impossible, or probably there's no solution. The reason behind that is if you square 2, you get 4. If you square -2, you get 4 as well. So there's no way that you can square a number to get a -4. There's no way you can square a number to get a negative number, period. So a scientist came along and said, okay, why can't we create a number, and let's call it I, and this number is going to stand for the square root of -1. And this way, we don't have to say impossible or no solution anymore. We can actually solve something like square root of -4. So instead of writing square root of -4, we can say square root of -1 times the square root of 4. So we can replace this with an I and just say I square root of 4. So every time we have a negative under the radical, we can replace it with an I. And then square root of 4 is something we can work with. For example, 4, in this case, as you can see, can either be the square of 2 or it can be the square of -2. So the square root of 4 can be plus or minus 2. And since there's a negative under the radical, I'm going to replace it with an I. So as you can see, you move the I to the solution. So I think it's time to go back to our complex number then. So what is a complex number? What could be an example of a complex number? If I give you something like this, 2 plus 3i, as you can see, it is made up of a real number, which is 2, and an imaginary number that is 3i. So 2 plus 3i is a complex number. So in this lesson, we're going to learn basic operations like addition, subtraction, multiplication of complex numbers, solving things that would require imaginary numbers. So let's see how we can solve something like square root of -144. So remember, every time you see a negative under the radical, you can replace it with an I. So the square root of 144 could be plus or minus 12. So you can write your number as such, or you can say plus or minus 12i. Since the square root of 144, so you show me that it's I, square root of 144, I, and then this could be plus or minus -12, and you can write this as plus or minus I12 or plus or minus 12i. So this is what we do if you have a perfect square like 144. And as you can see, the second example is also a perfect square. So every time you have a negative under the radical, you can replace it with an I. Now think of the square root of 25. What is that? It's plus or minus 5. And don't forget to copy the I. Now what if we don't have a perfect square, like number 3? In this case, what do we do? In this case, we have to do something called prime factorization. Try to think of all the prime numbers that would multiply to give you 75. But before we do that, remember to replace the negative under the radical with an I. So I square root of 75. And think, what two numbers do you think you can multiply to get 75? 25 and 3. 3 is a prime number, so circle that. And then what multiplies to give you 25? 5 and 5. These are prime numbers, so circle these two. So in this case, you can see that 75 is equal to 5 times 5 times 3. Every time you have a pair of a number, you know that these, or the 5, will go outside of the radical, and 3 is going to stay inside. So square root of 75 will become now 5 square root of 3. And the reason 5 left the radical is because we have a pair of the 5. You see that? Okay, so then the final answer would be plus or minus 5 radical 3, and don't forget the I. So as you can see, no matter what, every time you have a square root, your answer will always be a positive or a negative. Remember that. And if there is a negative under the I, always remember to put a negative under the radical. Always remember to put an I in your solution. So go ahead, try number 4 and check with the answer key. And now we're going to go to addition of complex numbers. So we covered now radicals of perfect squares, how to simplify radicals, and now we're going to cover how to add complex numbers. Now, as you can see, there's an addition between the two parentheses. So parentheses really don't matter, so you can just copy the numbers without the parentheses. Because remember, you're just adding them, and addition does not change the sign. So now you need to combine like terms after you drop the parentheses. So 7 minus 12 would give you a negative 5, and negative 8i and negative 4i would give you a negative 12i. Now remember, we cannot add these together. Since negative 5 is a real number, 12i is an imaginary number. So then that would be your final solution. Now go ahead and try number 7 and check with the answer key. And the next thing I'm going to do is subtraction of complex number. Now, the negative does affect and does make changes. Because if you distribute the negative, it's going to change the sign of 7 plus 3i. Now, this one does not have a negative in front of it, so you can just copy it. But the negative will change the 7 into a negative 7, and would change the plus 3i into a negative 3i. There you go. Now, after you distribute the negative and you change the sign of 7 plus 3i, you will get this. So now you need to simplify this by adding like terms. So 10 minus 7, that would give you a 3. And negative 4i and negative 3i, that would give you a negative 7i. And that would be the final solution. Now, go ahead, try number 9 and check with the answer key. So far, this is what we did, addition and subtraction. Now let's move on to multiplication. Now, as you can see here, you have 3 things to multiply together. So let's start by multiplying the 3i by the negative 2i. 3 times negative 2 would give you a negative 6. And I times the I would give you an I square. So what you do is that you multiply 3i by negative 2i, and then you copy the 5i, because now you need to work with this and try to simplify it. Now, another big idea in this lesson, we learned that if I is square root of negative 1, then I square means I need to square the square root of negative 1. And every time you square a radical, what's going to happen to the radical? It's going to go away. So I square is equal to negative 1. So every time you multiply and you get an I square in your solution, you have to replace it by negative 1. You should not have an I square in your solution. So I'm going to replace I square by negative 1 and copy down the 5i. So negative 6 times negative 1, that would give you a 6 times 5i, and that will give me a 30i. And that would be my final answer. Now let's move on to another example, like number 10. As you can see here, we have 2 complex numbers that we need to multiply together because between the parentheses we have no addition or subtraction. So in order to do that, you have to, first step is to FOIL. So you need to multiply the 7 by the 2 and then negative 3i. And after you multiply the 7, you have to multiply the negative 6i by 2 minus 3i. Now 7 times 2 will give you a 14. 7 times negative 3i would give you a negative 21i. Negative 6i times 2, that would give you a negative 12i. And the negative 6 times the negative 3 would give you a positive 18. And don't forget that both of them have an I, so when you multiply the I by the I, you will get an I square. Okay? So the first step is to FOIL, and the next step is to combine like terms. So, as I can see, I have a 14, so I'm going to copy it down. I have a negative 21i and a negative 12i, so if I combine them, I get negative 33i. Now I'm going to copy the 18i squared down. After you FOIL and you combine like terms, your second step is to replace I squared by negative 1, so you need to memorize this rule. You can never have an I squared in your answer. So instead of the I squared, I'm going to put negative 1, and that's going to change the sign of the positive 18 to a negative 18. Okay, so then, you see what I did? I forgot to copy the I down. There's an I in the negative 33. So then what's going to happen is that I'm going to combine the 14 and the negative 18 to give me a negative 4, and I'm going to copy the negative 33i down. So that is how you multiply complex numbers. Now go ahead and try number 11 on your own. Now the same concept, you need to multiply the 3 by the 3 and the negative 4i. And then you need to multiply the 4i by the same thing. So 3 times 3, that would be a 9, minus 12i. And then 4i times 3, that's going to give me a 12i, minus 16i squared. Combine like terms, these cancel out. You're left with 9 minus 16i squared. You cannot have an I squared in your answer. You have to replace it by a negative 1. So 9 minus 16 times negative 1, that's going to give me 9 plus 16, which is a 25. So as you can see, my final answer is a whole number because the I, or the imaginary number, is cancelled out. So that's how you multiply complex numbers. So we discussed addition, subtraction, multiplication of complex numbers. We also discussed how to simplify perfect squares and how to simplify not perfect squares, and how to simplify radicals in general. So now we're going to move on to the solve equations. Now, whenever you want to solve an equation, your first step is to isolate the x. So what I'm going to do is I'm going to subtract 3 from both sides. So I'm going to be left with 3x squared is equal to negative 3. Now remember, you need to isolate the x squared. You need to keep it by itself. So you need to divide by 3. So x squared is equal to negative 1. Now I want x, not x squared. So to get to x, I need to square root both sides. So I'm going to be left with x is equal to square root of negative 1. Now remember, I cannot have a negative under the radical, so I should replace it with an I. Okay? Now square root of 1 could be either plus or minus 1, so I can just write plus or minus I. Now let's move on to another example, but I would like it if you pause the video and try number 18 on your own. Now remember, you need to isolate the x squared by subtracting 72 from both sides. Then you have to divide by 8. So you get x squared to be equal to negative 9. Now remember, I need x squared, so I need x. So I need to square root both sides. So I get x to be equal to the square root of negative 9. And we learned how to do that. The first step is to get rid of the negative by putting an I on the outside. So I square root of 9. Now square root of 9 could be either positive 3 or negative 3. And don't forget to copy the I. Now let's try to move and do another example like number 16. Okay, in this case I need to move 16 over. So negative x squared is equal to positive 16, but I need x squared. I don't want negative x squared. So divide by sides by negative. You get x squared to be equal to negative 16. Square root both sides because you need x. We cannot have a negative under the radical, so I replace it with an I. Square root of 16 can either be 4 or negative 4. And don't forget the I. Now, that's everything I want to say about this lesson. Now, go ahead, do the rest of this. Maybe I would like to do one fraction. So let's do number 20. But you can do the rest of this practice sheet and check your answers with the answer key. Now, the first step is you need to subtract 54 from both sides. So you get 2/3 of x squared is equal to negative 54. Now if you have a fraction on one side and you want to get rid of that, you need to multiply the other side by the reciprocal. So what's the reciprocal of 2/3? It's 3/2. So to get rid of this, multiply the negative 54 by the reciprocal of 2/3, which is 3/2. Now if you do that, negative 54 times 3/2, you're going to get negative 81. Now remember, you need x, not x squared, so square root both sides, and you get x to be equal to square root of negative 81. Replace the negative under the radical with an I. So the square root of 81 can either be positive 9 or negative 9, and don't forget the I at the end. Now this means that x can be two numbers. It can either be positive 9i or negative 9i. Now I hope that this tutorial was helpful. Please check the practice sheet for more practice.